Hi, it's me, Paula, the math tutor, and in this video we're going to discuss measures of center and spread of a continuous random variable. For that, first we're going to define what is the mode, the mean or expected value, the median, variance and standard deviation of a continuous random variable. Of course, getting what we know from the discrete random variables. Then we're going to compare how we calculate those with a continuous situation and with a discrete situation to see that they actually make sense. It's the same idea, just that in a continuous situation rather than in a discrete situation. So let's begin. We want these definitions for measures of center and spread to make sense of what we know about these measurements in other situations, for example, in discrete situations. So we're going to take what we know from there and translate it to continuous. For example, the mode. The mode we know it's the most common result. In this case of the continuous random variable, we're going to say that the mode it's the value with the more density. The mode, let's call it x, is the value that makes f of x to be maximized in this domain. Then, for the median, we know that the median is the value that happens exactly at the middle, where the cumulative frequency is 50%. Taking that to the continuous realm, we're going to say that the median it's the value of x where the integral between a, the beginning of the domain of this variable, and that value x of f of x dx, it's 1/2, exactly 1/2. Then, for the mean, or the expected value. Remember how we calculated the expected value? We multiplied the values of the variable times the probabilities and then we added them. Because now we're in a continuous situation and we can't do that anymore, what we're going to do is we are going to calculate the integral between a and b of x times f of x, of the value of x times the probability density function dx. Then for the variance, again, if you remember the formula for variance, what we did is we found the distance between the value and the mean, we squared that and we multiplied times the probability. In this case, if we translate it to continuous, we're going to be calculating the integral between a and b of x minus mu squared times f of x dx. And for the standard deviation, which is the square root of the variance, we're going to calculate the square root of what we just found. Comparing these formulas with the discrete formulas then. For mu, for the expected value, for the mean, in the discrete situation it was the sum of the x's times the probabilities. In the continuous, it's the integral of the x's times the probability density function. In the case of the variance, with the discrete variables, we calculated the sum of each of the values minus mu squared times the probabilities. Now we're calculating the integral of the same thing times the probability density function. And the standard deviation is the same, it's the square root of whatever you got for the variance. See how they make sense? It's the same idea, just that instead of this being discrete and we're just adding each of the cases, we need to work with a continuous area, so we're working with the integral. And this is it for this video. In the next one, we're going to introduce one of the most famous distributions for continuous random variable, and probably the most useful one, which is the normal distribution. So I hope to see you there. Bye bye!